All right, math fans, today we're looking at exponent rules. So, remember, these were our basic rules that we picked up in the beginning of the year. Then we're going to pick up and we're going to review negative exponents and the zero power as well. Remember, so, when we multiply like bases, we just have to add the exponents. So, here we have x multiplying x to the n times x to the m. It's just x to the n plus m. That's old stuff. Dividing like bases, we subtract the exponents, okay? Now, when it's written out as a fraction like this, we can write it this way, n minus m, or else you can say 1 over m minus n. And I always like to do, when it looked like this, the large exponent minus the smaller exponent. That avoids negative numbers. Whenever you subtract, I always put the bigger number first minus the smaller. That avoids negative numbers. Okay? We'll get into that when we do our problems. All right, a power to a power, that's right. We just multiply exponents. So it's x to the am times y to the an when we have this expression raised to the power of a. Notice there's no plus sign there or anything like that. This is a product inside here. So we distribute the a to both. Okay, the power rule, this power to a power actually comes from multiplying like bases. Okay, and then negative exponents comes from division. Depending on how we subtract, we can end up with negative numbers. Okay, so a negative exponent, we just flip the base, and your exponent becomes positive. And then we have zero exponent, that's equal to 1. Anytime you have any number raised to the zero power, that is equal to 1. And again, that comes from subtraction, or division. Okay. So in other words, if these two exponents were equal to each other, when you subtract them, they would be 0. So, but what happens when you divide two numbers that are identical to each other? That's right, they equal 1. Okay, so anything to the 0 power is 1. So these are our 1, 2, 3, 4, 5 rules, okay, that we're practicing with today. So here's a big ugly mess right here. I'm analyzing it very, very carefully. And look at this. I have all of this, right, this product, and then this exponent right here, negative 3. Oh my God, don't worry. Folks, don't worry about it. It's a negative exponent. Okay? We handle negative exponents just like we do regular exponents. A power to a power, all we have to do is multiply. So what am I going to do with this? 2 to the negative 1 and the negative 3? That's right, we're going to multiply. Then that's going to say x to the negative 3. So this right here simply becomes 2, well, negative 1 times negative 3 is 3, and then it's x to the negative 3 power. And now what is 2 to the power of 3? That's right, that's 8. So I have 8x to the negative 3 power. Now I just have to multiply everything else out. 3x squared, y to the third, 7x to the negative 3y. And I'm going to follow my rules. Okay, we start by multiplying the coefficients together. So it's 3 times 7 times 8. So that's 21 times 8. That's 168. Okay. Now I'm going to go alphabetical order. So it's x squared times an x to the negative 3 times an x to the negative 3. I don't care that these are negative exponents. What do we do when we're multiplying like bases? That's right, we just add. So it's an x, and then it's a 2 plus a negative 3 plus a negative 3. That's right, that gives us negative 4. If you're not sure, type it into the calculator. 2 plus negative 3 plus negative 3. Okay. All right, now y's. Y to the third times y to the first, and there's no y over here to worry about. So we have y to the fourth. Okay. All we did was added exponents. Now, my rules, when we do this simplifying, I should have said this. Simplify positive exponents. Okay? So right now I have a negative exponent right here. So how do I take care of this? That's right, I have to do the reciprocal of it. What's the only thing being raised to the -4 power? That's right, it is just the x is being raised to the -4. So that means we're going to have a fraction. Oh my lord, we have a fraction. So put your fraction bar. What's on top? That's right, the 168 and the y to the 4th. Where does this go? It simply goes to the bottom with a positive exponent. So it's 168 y to the 4th over x to the +4. And we are done with the problem. Okay? Notice I didn't freak out about negative exponents. Oh my God, no. I followed my rules. I worried about this I worried about my negative exponents when I was all done with the problems. Okay. Power to a power, I multiplied my exponents out. All right, let's look at number 2. All right, number 2, I got some 0 powers. All right, so we have to multiply this out. But before we start multiplying out, we have to take care of our, remember your order of operations, inside parentheses, nothing inside parentheses to do. And then we do exponents. So what is being raised to the 0 power? Right, this whole thing is being raised to the 0. Anything to the 0 power is, that's right, 0 exponent, anything to the 0 power is 1. So this big ugly mess right here, this 7x, all of that to the 0 power, all of this is simply equal to 1. Okay? Now over here, what is this? What is the only thing being raised to the 0 power? That's right, it's just the x. So just the x is being raised to the 0 power, so that's 1. So what are we actually looking at then? A 1 times an 8 times a 1 times a 6. So that gives me 48. And then there's no x here, there's no x here, just x. We're done with the problem. This whole thing was 1. Anything to the 0 power is 1. This whole thing was raised to the 0, so that's 1. The only thing to the 0 power here was just the x, so that's 1. So 1 times 8 times 1 times 6. And we're left with and the x. Okay. All right, let's look at our number 3. All right, we're simplifying. There's a fraction here. All right, what are we going to have to do? Oh my God, there's negative exponent. Don't care that there's negative exponents. Follow your rules. First of all, let's take care of 18 and 27. Here's what I'm going to start by doing. I'm going to put this is a fraction, so I'm going to make one big giant fraction bar. If I have nothing on the bottom, then my answer is underlined. If I have stuff on the bottom, then I already have my fraction bar taken care of. So the first thing that we have to worry about is 18 and 27. What do we do with those? That's right, we reduce. What goes into both of those? That's right, 9. So I have 2 over 3. 9 goes into both. Now, a to the -3 over a. Oh my God, there's a negative exponent. I told you, you don't care. All you worry about is following your rules. When we divide like bases, we subtract. And then what did I say? We always subtract the large exponent minus the small exponent. What's the exponent on this a? That's right, it's a 1. Okay? Now, which one is bigger? A -3 or a 1? What's larger? That's right, 1 is bigger than -3. So we do our subtraction. The result goes on the bottom. When we do our subtraction, we always subtract to the larger value. Wherever the larger exponent is where the answer is going to be. So we're going to have an a on the bottom. And now we have to take care of the exponent. So it's literally 1 minus -3. Well, what's 1 minus -3? That's right, that's a 4. Okay, so that equals 4. Now I'm going to take care of the b's. All right, again, negative exponents. Oh my God, I don't know what. No, we just have to subtract. Where's the bigger exponent? It's on top. It's the 4 is on top. So we're going to have a b on top. Okay? So we have a b on top, and now I just have to subtract. 4 minus a negative 3. And what's 4 minus a negative 3? That's right, it's a 7. All right, and now we're looking at the C's. Where's the larger exponent? It's on the bottom, so we're going to have a C on the bottom. And then we're going to just do 2 minus negative 8. And that's right, it's a 10. We just simplified the problem. So we have 2b to the 7th on top, and then 3a to the 4th, c to the 10th on the bottom. All done. I didn't freak out I had negative exponents, and I'm like, no, I just did my subtraction. Some teachers would say, hey, you got to move this down below, then do your work. Move this up, then do your work. Why bother? Why? Follow your rules. Big minus small. Big number minus a small number always gives you a positive result. Big number minus a small number always gives you a positive result. Big number minus a small number always gives you a positive result. Works every single time. Okay. Let's go see what else I have for you guys to do. Okay. All right, got some wackiness up top here. All right, let's take care of this. So we have to multiply. We have to raise to the negative 2 power. So what do I do with these exponents? I have to multiply, but what do I do with 3? It's right. It's literally 3 to the negative 2 power. So I'll write it out. I'll write out 3 to, yeah, I'll write it out. 3 to the negative 2, and then it's a to the negative 4, b to the positive 6. How did I get positive 6? That's right, negative 3 times negative 2, and then 2 times negative 2, and then 3 to the negative 2. What is 3 to the negative 2? That's right, that is a 1 on top over 9. Then I'm just going to write everything else out. Okay, times, what's the only thing being raised to the negative 2? That's right, just the b, so I'm just going to rewrite. Okay. Now, I'm looking at this right here. I see a 1 over 9 times a 4. That's going to be a fraction. So when I do this, I'm going to put one big giant fraction bar. So now what do I have on top? I have a 1 times 4, and then I have a 9 on the bottom. Now I'm going to take care of my a's. A to the negative 4 times a to the first. What do I do with exponents? That's right, we add. So that gives me an a to a negative 3 on the top. And what about the b's? All right, we add. So b to the 6 times b to the negative 2. We add those exponents, so I have b to the 4th on top. Now I will worry about negative exponents. I want positive exponents only, so where do I have to move this? That's right, we just have to move it down. So we have our final answer of 4 over 9. Ooh, make my fraction bar bigger. This a to the negative 3 goes down below as a positive exponent, and I have b to the 4th on the top. There is our final answer. All we did was use our rules. Notice I did not freak out about negative exponents. I just followed my rules. Then I worried about moving those negative exponents when I was done. All right. Now, before we get into 5, I want us to look at this. What does this actually mean? It's 2 to the negative 3rd over 5 to the negative 2nd. I'm going to follow my rules. So this is right. This is 1 over 8. And how did I get 8? Right, 2 to the 3rd is 8, but we had to say it's a negative exponent. Folks, by the way, if you're not sure, pull out your calculator. And make sure you have a calculator that can change things to fractions. For those of you who have a graphing calculator, math, enter, enter. I have my scientific calculator. It should be able to do it. So I have 2, turn it on. On this calculator, I have to use this x raised to the y. So it's 2 x raised to the y negative 3, hit equal. I have this decimal. Now I just have to change it to a fraction. So that's shift in this button right there, 1/8. So I have 1/8 on top. That's right, this is 1 over 25. If you're not sure, that's what this thing is for. Now, how do I clean this up? Yes, we can multiply by the common denominator. How about this? Isn't this saying 1 over 8 divided by 1 over 25? Isn't that what that means? 1 over 8 divided by 1 over 25. So now what does that mean? That's right, we keep, change, flip. So doesn't that just become 25 over 8? Now look at that. So this 1 over 25 just becomes a big giant 25 on top, and this 1/8 just becomes a big giant 8 on the bottom. So 5 to the negative second goes to the top as a 25, and then 2 to the negative third went to the bottom as a big giant 8. So we had 25 over 8. So let's see if we can do that down here. So it's 6 to the negative 2. Where does that result go? That's right, that result is going to go on the bottom as what? That's right, to the third. It's 36. And now 3 to the negative 3, where's that result going to go? That's right, that's going to go on top as a 27. How do I get 27? 3 to the power of 3 is 27. Okay? So in other words, this is what you just did. We just had a 1 over 36 over a 1 over 27. So I just did this up here again. So I just flipped. Put this at the top, put that at the bottom. Move this up, move that down. Okay? So we had 27 over 36. All right, let's take care of everything else now. What am I doing with those two? Right, I multiply, so that's c to the positive 2. And then I have d to the negative 2. Okay, multiply, all right, so I have c to the negative 9. And then I have d to the positive 6. All right. Now all I gotta do is reduce. Let me do it this way. All right, what goes into 27 and 36? That's right, 9 does. All right, 9 goes into 27, 3. 9 goes into 36, 4. So I have 3 over 4. Now I'm going to take care of my c's. Where's the larger exponent? That's right, it's at the top. 2 is bigger than a negative 9, so its c is at the top. And it's 11. How did I get 11? That's right, 2 minus a negative 9. And then the d's, where's the larger d? At the bottom. So it's d to what power? That's right, d to the 8th. And again, how did I get 8? 6 minus a negative 2. There we go. Problem simplified. Okay, we used your exponent rules. That's all I did was my exponent rules. All right, folks, good luck with your assignment.